So this topic mainly to discuss about the latest development or some development we have been encountering. So we're going to discuss different kind of EV model, maybe some commercial vehicle you're now having, and also some comparison among different model from different brand or maybe from different country. It's a quite simple topic. Actually, I think if you're anyone driving an EV, you may really much familiar with them. So here we'll give you some overview of what's happening. Mm-hmm. Yeah, moving. So firstly, I have a page for the target question. So what do you think, which one is the top model for EV nowadays? Anybody can tell me if you're buying an EV, thinking to buy an EV, which one is the top model you're thinking? What do you think? If you're going to get a few more EV, which model are you going to get? Tesla Model Y. Model Y, oh yeah, good. How about you? What do you think? Which one?
I will one day for now.
Okay, what's that?
I think the petrol.
How about you? What do you think? Which model you like to get?
I think model for popularity worldwide.
Yeah.
I think probably Model Y or one of the BYD ones.
I think this is Model Y is the size is quite comfortable, better than Model 3, but quite different by about 10,000, very much accessible. How about you two, what do you think?
BYD.
BYD, okay, it's much lower cost, right? But you can't buy BYD here. You know, BYD is a really good brand in mainland China, but since we have difficulty to get in here, you think about how to do that. How about the two gentlemen? If you want to buy an EV, right?
Model Y.
Model Y, yeah. How about you? Model 3? Yeah, cheaper. Yeah, cheaper, low cost, and good enough. Means if you don't want to a 7-seater, then Model 3 will all quite okay. Yeah, I'm also thinking about that. And my wife told me we try to buy a Model Y this week. We can. I'm not quite sure she'll do that or not. Yeah, but the financing will cost me about $800 per month. Anyway, so I mean, EV is now getting really popular. It seems that the top model actually go to Tesla, certainly. But in other side of the world, like in Asia, BYD is also a top model there. But in China, Tesla also a top model. So it seems over the world later on, we can see some statistics. Then it seems that Tesla and BYD are top model among everything. So that means in 2025, it's coming this year, then you may predict which one is the top model. But I don't see any other big manufacturer will able to encounter all the effort by BYD or Tesla. I guess these two is still the top model in this year. But the one of the question I also last week will be, we have more EV, we're going to have more power emission from the power plant anyway. But my answer will be, I like that because the total emission still reduced. We just move from the roadside emission to the power plant. But nowadays, the main problem is we don't have sufficient power source. That is to say, if you want to get a high power charger, after you buy a EV, you need to install a bigger charger rather than standard one. Standard one will be just slow charger, like from the power plant, you go to charge it, but it take you many hours, I think more than maybe 30 hours, maybe 40 hours to charge up. But however, for power charger, not all the house able to install high power charger. Like in many of the charging stations here, most of them will be slow or medium. So that means in the future, we do need to install more high power or so-called fast charger. But the problem is we don't have sufficient power distribution. If you ask PG&E to give us a new power line for high power, probably you may need to wait for many years. So that's the issue. We're not quite sure how to do that. We like more EV, have low energy, low power. How are we going to do that? That's why I recommend to my students say, I think now the unique thing about the new business, probably EV charging station. Have people install a power station. We got many techniques how to overcome the problem of the energy management from PG&E. So we still have thinking about that. So that could be a really good business. You can see that today we only 2% of the vehicle electric, but probably after 10, 20 years become more than 50. Then the business is so good. You can't imagine that the investment is not that expensive because only about installing the charging station. It's not really complicated technology. So probably we don't need to manufacture it. We buy from the manufacturer, install it, and then get some method to get the power from a power company. So that's the key technique you need to do that. And the location also quite important. So that's something you need to think about that. That will be one of your startup in the near future. That will be a good business anyway. So after you study my course, I'll tell you more detail, my thinking, how to develop our EV charging enterprise. Anyway, so the content today is not really high content. We talk about some worldwide EV development to look into different brands and also some modern EV development. So that's the thing we try to look into. Firstly, of course, we know that the biggest development will be in here. I mean, China, we got a very good brand like the BYD. And so in US, there's of course, Tesla is also one of the big one. In Germany, we also have Mercedes, Volkswagen, and BMW. They don't have that many EV at the moment, but at least they got a few models in this area. So they're not developing, but the market share is not very good. So that's why the major market can see the top two will be from China and United States, mainly about BYD and also Tesla. And Japan also have a lot of development. But you see, Japan is now slightly lagging behind because they have been focused on hybrid electric, like the Toyota Prius and maybe even the hydrogen hybrid. So it takes a much longer time for the development. Anybody can tell me, Japan has been focused on hydrogen hybrid. What's the issue for hydrogen hybrid? Why after 20 years? I think they have been developing the hydrogen hybrid for more than 20 years. Still, the market share so little, right? Everybody can think about any problem, any reason? Do you see any hydrogen hybrid here in California?
Infrastructure. It's difficult to develop a wide scale infrastructure for those cars.
Okay. You see, that's what you say is really correct. A cable structure is quite straightforward. Lay down a cable with the power. But to install hydrogen piping is really complicated. You scale about the leak gauge, the safety, the size. The cable size must be much smaller than the pipe, right? So that means to do that will be difficult. Also, you can allow the charging station next to your house. Probably you don't like a hydrogen station next to your house. Why next to this is a big energy storage tank? As I mentioned, hydrogen storage will be 700 bar. Not even though the hydrogen is explosive, the high pressure will destroy your house. So nobody will like that. So that's why the development for hydrogen is just so slow. So that's why I think, although Japan are choosing using hydrogen, but I think they regret so much. Now the automotive development has been overtaken by many other countries, including BYD and Tesla. Probably they can still stay on with the gasoline car, but not for too long. Probably by 2035, right? Then they will have a big problem anyway. And South Korea has been working quite well, like Hyundai are quite good model. They do have quite a few more though in electric car. And France as well, like the Renault and Peugeot, also quite a good brand. They don't have that many, but they still have a couple of them. And UK as well, and Land Rover, and all. So they all have quite a good brand anyway. But you can see that each country, each major manufacturer over the world, they do have quite a few brands. But still, the branding in other countries, still not that many. They still need to gradually move on to electric because they didn't think about how to move on gradually. Too many manufacturing plants, too many workers in this area. So they're not quite sure how to move on. So for example, like this is some of the brands in China and in United States as well. So they are all quite a major supplier for the electric vehicle. And also here in Germany, and also in South Korea. So now then you have a quick overview of all the EV and supplier or manufacturer. So it seems later on I can show you some table. It seems the BYD and Tesla account for major percentage. I think probably more than 80% anyway, maybe approaching 90% for the whole world market. So that's why the other companies still catch up. But anyway, I think eventually other companies may catch up because the market is so big. Nowadays, I think in average, I think only just a few percentage of all the EV. But if in the near future we go up to 50, 70%, I think all the other companies will catch up. So we don't need to worry too much about you only stay with BYD or Tesla. So other companies will also come out because as I mentioned before, many people like some luxury car. For example, like Rolls-Royce, BMW, and Lexus, they like some famous brand. So in this case, probably they like the electric version of all this vehicle because you look good, you look better anyway. So I think that for the next 5 to 10 or maybe 20 years, there's a very big changes in EV development. And by that time, we may not using EV, we may have other type of the vehicle. We're not quite sure what it is, but I don't think vehicle is the way we have. Now maybe we have some robotic vehicle, maybe fully automatic. So that means we don't need to care too much about there's a vehicle or a moving office. But anyway, so you see the EV absolutely is not new. As you can see there, has been developed, invented 180 years ago. During that time, we had the motor development, we got the battery development, put them together, become our EV. So 100 years ago, coexist EV and also combustion engine. So that's why I mentioned before in beginning of 20th century, these two are existing together, and EV has a really good market during that time. But because EV losing the competition, ICE dominating the performance in terms of the mileage and the power, and that's why ICE vehicle become dominant for the last 70 years. So now then, EV are basically using a powertrain, electric powertrain, and gasoline car are more using mechanical powertrain. These two are quite different, and the electric motor based on the capability of the battery. If the battery is able to do a good job, then EV certainly will be the winner. At the moment, still people are not quite sure about EV because EV battery system use about say 500 km, but you can't get a low-cost solution for 1,000 km mileage per charge. That it seems too expensive or impossible. So most of vehicle, maybe 300 something miles per charge will be quite reasonable. And anything more than that will be getting difficult, especially a private car, because you need to install more battery. You can have a long mileage per charge, but the number of battery installed will be too heavy and too much. It's not really sensible for a private vehicle. And then you go to a truck. At the moment, we see very little truck in the EV market. Why is that? Because many trucks, if you put too many battery, they will be too heavy. All the payload will go to the battery. So you've got little room for your loading. So for example, like a 5.5 ton truck, the battery can go up to 2 to 3 tons. So 5.5 you minus the 3 tons, you only got 2.5 tons for your cargo. That's not worth to do that. So that's why we do have a problem, especially for truck movement. You usually need to travel long distance. Not in public car, we can have city driving, but for truck, usually it will be cross-country driving. So in this case, we do need to have a good battery system. So that's the issue. We have a lot of problem for the EV development, especially for commercial vehicle or for large vehicle. For private car, we still have problem about the battery. So that's why the major issue for further EV development is mainly about the energy storage. So we need to look into a new battery system, probably a new energy storage system. Then, of course, ICE combined with EV will be a good solution called the hybrid electric, because we can able to use gasoline to charge up the vehicle. So that in a way, that could be another good solution as well. So that's why you can see that hybrid electric is still a major player in this EV or automotive market. I think 20 years ago, people talk about hybrid electric could be only a transition solution. Gradually, we can move to 100% EV, but since still not yet in this thinking, we still can see nearly 1/3 of the manufacturing of vehicle are hybrid, because we think using gasoline hybrid could still quite a good solution. Although we are not 100% zero emission, but at the moment, if the people enjoy the long mileage, then hybrid is still quite a usable solution. So for the EV development, I think the early EV development mainly go into the two early vehicles. You can see that Mississippi i-MiEV that developed in 2009, and also Nissan Leaf that was launched in 2010. Roughly about that time. During that time, there would be two major vehicles. But see that when we try this vehicle during that time, it really is good, but the thing is too squeezy. Quite so small, probably you don't quite like to use it for a long period of time. And then Tesla, during the time they launched their first vehicle called Roadster, which is really good because the mileage will be 394 km. During that time, it's supposed to be quite a long-range vehicle. Of course, really expensive, close to about more than 100,000. And they're using, of course, lithium iron phosphate battery. The performance is really good during that time, and also the acceleration, I think pickup is really good. I think the 0 to 60 miles, I think something like close to 4 seconds. During that time, supposed to be really good vehicle as compared to other. And then this vehicle, the car body are folded from Lotus. So this really good looking car body. So that's why during that time, Tesla make the name during that time, become one of the really famous EV during that period of time. Here will be some picture you can see from the early version of the i-MiEV. So you can see that the vehicle are quite small, tiny. So 4 passengers together will be quite squeezy, not really comfortable. And the acceleration, the range is not really comfortable. You see the battery is quite small, about 16 kWh. So I think 5 times less compared to today. In that time, they're using lithium iron phosphate battery. The battery capability is not really good. So this kind of the battery, probably the mileage can only go for 160 km. But in the car, supposedly to be really good anyway. But the main problem is the aging for this battery is really fast. When you buy this vehicle, 160 km range, but after probably 1 year, it dropped down to, anybody can give me a hand, how much do you think the battery mileage will therefore reduce from 160 to how much after 1 year? 100, something like that, 110. And then together, if you use them in in the summer, you may need to turn on the aircon. Then the aircon will consume around 25% of the energy. So probably the resulting mileage will be less than 100. So it's not really usable. So then the people will complain about this vehicle. You need to drive for a few times. You need to look up for the charging station really important. In that time, all the charging station, so the standard charging station, then it's slow charger. You get about say 10 hours to finish the charging. So that's how the vehicle look like. They are, of course, because it's a Japanese brand, they use the CHAdeMO. I'm not quite sure you know about the CHAdeMO, one of the major charging standard in Japan. During that time, the major vehicle mainly come from Japan, like Nissan and Mitsubishi. So that's why CHAdeMO become one of the major standard during that time. Many people like to use it. The CHAdeMO later I will talk about a bit more. They have a high power charging to medium charging, and they gradually move on to more high power charging now. So something close to 100 kW of power will also allow maybe even more than that. So that's one of the history of the development. I don't think today, I can't see anyone will buy the iMiFi, but it's one of the good part of the history. Another major work during that time, 15 years ago, would be the Leaf. Leaf is somewhat come out slightly 1 year after the iMiFi. Before a Japanese brand, this one is slightly better looking than the iMiFi. So the cell there that time in Europe and US are really good. It's 5-volt, and you can also charge in the front. You can plug in the charging. You can have a dual power charging, either using conventional power or using CHAdeMO. You can also conduct the charging. They are using the front wheel drive, and the first generation able to have 160 km. So the range is supposed to be also very good, similar to the iMiFi. And the motor, you can see the 18 kilowatt of the motor is quite a good power. You see the power level for motor may not be too significant. So firstly, the motor is really low cost, it's not expensive. The power density for motor is also really high. Even though 15 years ago, the power rating or power density for motor already really good. It's just the battery is not good enough anyway. And then they gradually move on to make a better generation, because during that time, Leaf is really demanding from the market. Many people like to have a Leaf because there's not many choices. During that time, you can go for Tesla. During that, Tesla are mainly about the Roadster. The Roadster version will be something like 150,000 per vehicle. Probably, but that if you during that time is tax free. If some country have tax, it will be plus 100%. So really expensive. So the another choice would be go for the Leaf. The Leaf during that time will be about 1/3 of the price. Still really expensive, but still feasible. You can still buy one. And so that's why many people, if they want to go for EV, during the time we all like to go for the Nissan Leaf. And then for Nissan Leaf, and the original price during that time roughly about say 500,000 to 400,000. But if a vehicle after 1 year old, then the price will drop by half. So during that time, many of my friends, they try to import the second-hand Leaf and then to sell it. So it's quite a good, and they can also eliminate a lot of the other costs. So that second-hand car during that time also a really good market. Since Leaf is quite popular, so that's why they gradually to move on to other good and subsequent model, like the 2024 model. So that is the power level, the mileage has been increased by quite a lot. That is mainly due to the improvement in their battery. So they're able to provide longer range. Of course, the extended range also available, can go up to 60 kWh. So if 40 kWh able to provide this, then you can say this one roughly can increase 50% of range. That would be more close to 500 km. That could be really much closely compatible to other, say, Tesla vehicle. So that's something we like to see. So that is the one of the vehicle many people will look into. It's also one of the important development in the history of the EV. Any question up to this point? Have you seen any Nissan Leaf here? No, probably not. I don't see one. I think In Hong Kong, we still see quite a few, but not in United States. I'm not quite in. I think in Europe, I'm not quite sure if you see anything from Europe. But how about Ali? Have you seen any, say, Nissan Leaf in Europe or in your country or wherever? Have you seen this kind of vehicle?
Not really.
What's the most popular model in your country?
In EVs,
Yeah.
most like recently BYD has like installed their plant in Pakistan, so we see not really like it's challenging, but still people are really excited about that. Other than that, other brands, not like Tesla to some extent, but very mostly it's not something. Taxation is too high.
Oh, yeah, that's true. I mean, 15 years ago, there's a no tax for all the electric vehicle. But gradually, most government found that is too not good for the income. They gradually to add back all the sales tax, all the vehicle tax in all the electric vehicle. So here we'll see some of the analysis for popular EV sales. So here will be a figure from 2022, that's the sales. Then to grow year to year comparison, then it increased by 32%. So that you can see that the increment for Model Y, Model 3 are one of the biggest. And then also you can see that the other model like Ford, Chevrolet, S and X. And of course, we don't see any BYD model in the United States. But major will be all this major model there. And then here will be some specification for the Model Y, I think. And I just get it from Wikipedia. So you can see that's how the performance like. Of course, you can also have some extended range, long range, able to get longer range of the performance. I think Model Y nowadays can add up everything will cost you roughly about 60,000 for 2025 model. If you want to go back to 2024 model, will be something like say 50,000. That will be still feasible. Here will be another one for the Model S. I think for family car, of course, we try to go for the Model Y because you can select either 5-seated or 7-seated. If you go for the 7-seated, then you need to pay extra $2,000 in order to add the extra seat. But the back seat will be really squeezy, so probably you don't like that. Many people just stay with the 5-seated, and the back can become a trunk for your storage. So that's how the Model S like. Model 3 and the Model X. So detail here is not important, that mainly to go through of you about the history of the development anyway. And then Ford Mach-E. So that's a price roughly about 43,000. The range is supposed to be 600 something, quite a good range anyway. And the acceleration will be 0 to 60 miles per hour will be 6.3 seconds. That's a comparatively quite good, really good. And the battery they're using 70 kWh. The motor is the rear-wheel drive. So some of them they're able to provide you with 4-wheel drive with front and rear. And the battery usually warranty for a certain number of years. For this model, they warranty for 3 years. But you see 3 years not quite sufficient, or able to warranty for 8 years if you're below 220 km. So I think usually battery will be degrade within a few years. even though they guarantee for 7 years, but you can see the performance will reduce by around 10% after about 3 years. So that means all depend on your mileage. So that means 8 years for 220 is not really sufficient. Probably you can find that during that time after you run for 220 km, the performance battery will degrade by about 10 to 20%. Once the battery degrade by 20%, the performance, not only the mileage, but also the power you can able to provide, and also about the accident rate. You can see that there's many battery accident, including explosion on fire. Usually will go to the aging of the battery. If the battery aging, then the chance of this will be higher than other new battery. So this one will be 33,000, range 500 something, 71. I mean, the vehicle will be conventional design. The acceleration 0 to 69, 6.5 seconds. It seems that will be quite long. The motor power will be 200 horsepower. That will be really much reasonable. And the range depend on the battery, 65 kWh. So you can see that most of this private car, the battery content are roughly between from 50 to 80 kWh. So 65 will be something like in the middle design anyway. And the battery guarantee to be 100,000. So compared to this one, 220, but this one, 100,000 for the battery. So you see this one is a little bit too conservative for the battery capability. Hyundai. So this one also really popular, probably not popular in here, but still quite popular in Asia. I can see many of these vehicles there. The key thing will be the price also quite reasonable, and also the range, and also the battery warranty is only about say 10 years or 100,000. The motor is not really high power. So 2024 model, they can able to travel for 600 something km, but that will be the special edition model anyway. So this is slightly reasonable price, but really popular in Asia. Volkswagen, so 40,000. The range about 600. The maximum horsepower really good. I mean, opposed to 300 horsepower, much higher compared to other vehicles. They got rear-wheel drive or all-wheel drive being available. So that means you can select for 4-motor or 2-motor version. You see, usually all these EV, they don't use single motor. They prefer to use 2-motor. So what do you think if using 2-motor? Do you think that will be any balancing for the 2-motor in case these two are not balanced very well? Will the vehicle not able to travel on a straight line, right? What do you think? Would that be an issue for 2-motor design, or you prefer a single motor design? What do you think?
The 2-motor is working should give a better acceleration and maneuver.
You think about 2-motor design, the control will be a problem. How do I ensure that 2-motor can be synchronized really well?
Powertrain.
With the 2-motor. If there any little bit of the speed difference between 2-motor, you can't control it that well, then the vehicle can run on straight line. Do you think that would be an issue?
I mean, that would be an issue with the single motor too. If the single motor is somewhat defective or something, then the car will run properly.
Single motor, that is you are using differential gear or more mechanical controller, so the deviation may not be too high. But you can imagine if you are using 2-motor, these 2-motor are not controlled really well, then probably you can't really go for a straight line in free.
Yeah.
So that mechanical control using differential gear if some people may think will be the case, but that's not the case anymore. Really, 80% of the EV in the market, they don't use single motor. They use two motor or maybe four motor. We gave up to use single motor. Single motor based on the thing we just change the ICE into single mode motor. It's a really simple retrofit thing. But that happened 20 years ago. Today we don't use that. So you can see all the specifications here. Most of them they either using front wheel drive or rear wheel drive. Either way, they have two motors. We don't use single motor. Or for all-wheel drive, that means four-wheel drive, we use four motor. We don't have any synchronization problem because the control method for motor today is really good. Not only today, 20 years ago or already very good. We don't encounter any problem for the control of the position and the speed of the motor. It don't happen. It's too simple nowadays. So that's why we don't have any problem for synchronization. So if we allow two motors to control the wheel, then that means that we can go straight line without any difficulty. It's very simple control method nowadays. So that's why you can see all the specifications here. They will using say rear wheel drive or front wheel drive or maybe all-wheel drive. They all using distributed motor, more than one motor, either two motor or four motor. It's not a technology anymore. It's a very simple technology, I should say. Another reason we use two-wheel drive will be the power distribution. You see, we slightly prefer low profile. We don't want a big motor. When you use single motor, that means total power will be focused on the single motor. The size of motor will be bigger. The profile will be higher. But when you use two motor, we distribute the power to the two sides. Then in this case, the total profile will become lower. Then the shape, everything will become better, right? Even if you four-wheel drive, you distribute your four motor, the total profile can be lower. You have less dragging force due to air resistance. So you want more flexibility to the design. That's why you can see the major problem for the digital EV and also the conventional vehicle. For instance, you can see that in the conventional car, when you go inside a car, probably you can see that you got the front wheel here. Then your rear seat. In here, we got the sharp. So when you sit on here, then you usually need to design your seat on here. So it's not that flexible. And some vehicles, they also have transmission in the middle. So that's why you can see that that will be another housing for your accommodation. This is a conventional car, or you use single motor to do it. So nowadays, when you are working on the four motor system, so we have motor in here, then also a wheel, and then a motor in here. They're all distributed. So in this case, we have no sharp in here. We don't have any transmission in here. So that's why we don't need to work. The design for the whole vehicle will be much easier than before. Inside, we can really flat. We can able to do a lot of the better interior design rather than before we've been restricted by the transmission and the sharp in here. So that's why present design, we all prefer to use all-wheel drive, four-wheel drive, or two-wheel drive because that perform much better. And some vehicles, they do have some accessory. Many vehicles today, they able to provide wireless charging, but not for the car. Yeah, only for your phone. So that's a quite straightforward, quite low cost. Many vehicles were able to put that in. But the thing is, we have been working on wireless power charging for electric vehicle, but still we don't see that many development for wireless charging for the vehicle. Anybody can tell me why is that? Wireless charging for phone is quite straightforward. You increase the power level, become the vehicle wireless charging. But do you see any model, any vehicle are using wireless charging? Not yet, right? Why is that? Why there are no vehicle working on this? What do you think?
Not sure. One of my friends is researching on that, and I thought it's really complicated, like to wireless charge the car. But I'm not sure specifically why is that.
Maybe, what do you think?
And I think it's an infrastructure problem again, because we already have plug-in everything set up. So there's really no incentive to do research in this area and then do, commercial rollout of wireless charging where we already have plug-in chargers everywhere. But those would have to be replaced or phased out. I'm assuming that the market share wireless charging goes up.
I think it will be just like the phone. The phone, we got the plug-in charging. We also can do the wireless charging. We can add another phone to appear. But the major problem here is for the phone, we only have really thin coil. We can do, and but in here, we can do wireless charging. So the thickness is not that significant as compared to the total structure. But for EV, of course, the coil also quite thin anyway. You see, for my research team, and we got 1/3 of my students are working on wireless charging. You see, still that time, many people like to work on wireless charging, but still no market yet. I guess what you say is really right. The thing is infrastructure. Secondly, will be all the EV development, you can't do any retrofitting. You must work with the manufacturer because the coil must be installed in the manufacturing stages. You can't install afterward because the EMI protection, you can't do it. So, but for manufacturer, they still really busy working on the battery system, charging system, the new design. They don't need to spend too much time on the wireless charging. And also wireless charging, the performance is not that good anyway. I think for high people today all looking into high power, rapid supercharge. They like to charge the vehicle within 30 minutes. But for wireless charging, no way you can able to achieve 30 minutes. Such a high magnetic field, you destroy the vehicle. And then you also need to worry about the protection against the EMI. So that means I think most effort of the EV manufacturer will be go to the total design of vehicle, the new body design, and also the battery system or the charging station. Many things they need to take care of. I think it need a few more years for them to start to think about the coil design wireless charging. And at the moment, we don't have that high power charging yet. For instance, for this kind of size, the maximum power probably can only become 2 to 5 kilowatt. That's too far away from sensible power to charge a vehicle. We like to charge a vehicle, as we mentioned before, 100 kilowatt. Yeah, such a high power for private car. But such a coil like that, how many coil do we need? And then would that EMI would be a problem? So I think manufacturers don't like to involve too much effort in wireless charging at the moment. They still like to do that. But I think probably in the next few years, not the first solution. Kia, also another one, also quite popular. I think you can see that 45,000 manufacturer subjective price will be 54,000, battery 58. Some of the version, the extended range version can go to 77 kilowatt-hour. So that means if 77 kilowatt-hour battery can range to go to 621 km, that's really good. Very better than quite a good number of models from Tesla or other brands. So here is supposed to be not a really famous brand, but still quite popular in the Asia too. So, but the battery warranty also not really interesting. 2,000 miles for the battery warranty. So here we can see how the battery life. Today, most of battery they are embedded in the car body at the more low part than in the chassis. So that's one. Today will be the major design for most of the vehicle. They try to make it really flat, so cover the whole chassis. And the motor will be either in front end or the rear end. So that's why the middle part, say the middle in here, will be mainly about the battery. So if anytime you can open up an EV, you can check where the location of battery and also location of the motor, that would be quite interesting. And the problem will be, if you want to install the wireless coil, then the best position Because front side is the motor, rear side could be the motor, the four-wheel drive, front-wheel drive. The only location you put will be under the battery. Then nowadays you think about if you have a high power charging for the battery, then you think about the insulation from the electromagnetic field. You do need to put some metal shielding between the battery and the coil. Because the coil you usually will be spinal coil. I think you all know the coil is just spinal. And then the bottom part will be also the spinal. That will be on the ground. That will be in your vehicle. Then in here, on the top there will be just, that is our vehicle, EV. So the battery we usually put on here. So now then you think about, would there be any problem? You always have high electromagnetic field go to the battery. Would that be have a certain heating effect, cause you another problem? How do you implement the shielding? So that's the total solution is not only the coil. You need to have some protection like some ferrite or electromagnetic item to isolate the magnetic field away from the battery. So the total fitness here will be another issue as well. So that's why wireless power transfer is still a major issue. Especially you can see that the structure for the battery will be like that. We need to put all the power underneath the battery. So R1T also start from 75,000, also quite a good price. And pickup vehicle, dual motor. The battery is quite large because mainly for pickup. So energy requirement will be also quite high, 180 kWh. So I mean, this kind of battery will close to a bus. Many of the bus or the minibus or maybe city bus, the battery are using roughly about 200 kWh. So mean this kind of battery energy level are really close to a bus anyway. They try to design for long range, plus they want to design for the pickup, for the cargo delivery. So that's why it will be like that. The maximum mileage, you can see that close to 1,000 km. That will be really good. So they can able to use four motor or all-wheel drive. That means this kind of four motor total power will be 835. So each motor will be more than 200 horsepower, quite high power. So now this is some analysis for 10 different models being shown in 2024, right? So you can see that Tesla Model Y is still the biggest seller. The next one is BYD Song. So it's still quite that's the second. The third will go to Tesla Model 3. So now they can see who are the winners. If you add up Tesla Y and 3 will be one of the biggest ones, right? But the other one, you can see that the top here go to knock all the market. And then all the other companies are really small as compared to them anyway. So that's why I can see that quite a big difference between top model and the bottom model. And then the rest of them, if you go down to the ranking about the 20, the number is so small. Just a few thousand. I'm not quite sure how they can survive. How a company can make a few thousand model can survive. So that's the other brand name, Hyundai, Volkswagen. So it's something quite interesting in the analysis for the last year. What happened to this EV model anyway? Then here will be some comparison in the 20. I have typo here. It's not 2022. It's 2024. Yeah, I change it back. Sorry. Suppose the 2024. So in 2024, first quarter, then you can see the plug-in vehicle and also all electric vehicles, the registration. So you can see that's how the comparison like. So that's our top 5 model in 2024 Q1, only for the Q1, not the whole year. So still you can say Tesla will be go to that. 19% share. BYD group, the whole group, including all their brand. So that including all their brand will be this kind of thing. We can see some smaller brand. And they are also quite a low cost vehicle, and the percentage also quite high anyway. But interesting thing will be for the plug-in vehicle. Here will be all electric. This one will be plug-in. The plug-in here will be BYD become the top seller for plug-in. And the Tesla, it doesn't have any plug-in, so only 16, and they have 16.5. So that's some type of the comparison you can see here. Page. Here will be the another comparison, 2024 Q3, the third quarter. That's the latest data I can get. We can see that in the US sale, that only for the interstate, the Model Y is still the top. Next one will be Model 3. Tesla Cybertruck also have a quite a good number. Next one will go to 4. So you can see the comparison between them. So the 2024 and 2023, you can see that the change surprisingly, then some of the number maybe increase a little bit. So it's quite surprising. Not quite sure why, but the YOY mean the stand for year-over-year comparison. So it happened to be Model Y slightly decreased by 9% compared to last year. Not quite sure why. But anyways, there's some interesting point. You can see that still Model Y and Model 3 still the top seller, including Cybertruck. Nowadays, I can go out and see many Cybertruck, quite a good portion. So since that portion, the number of vehicle, the ratio I can see outside, there's 16,000, there 86,000, offer different by 5,000. Here, I can see offer 20% of Tesla outside Cybertruck. So there's something quite interesting. Another less demanding brand like the BMW i3. i3 has been in the market for many years, but actually that could be quite a disaster model because the performance of the i3 is not really good. Although it has been in the market for a long time, but the mileage is not very good. The acceleration not very good. The vehicle is quite squeezed inside. So that's why probably is not that comfortable anyway. So that's why I think the sale for this one is not really the fault. I think during that time they first launched with 2013. During that time they launched the vehicle just right after the Nissan Leaf. They want to catch up the market. During that time, there's not many EV in the market. Besides Nissan Leaf, the next one could be BMW i3. But after that, there's many EV in the market. So that means this kind of the design gradually become not performing really well compared to others. You can see that the range is not very promising. And even though today the latest model, the range is not that good. So other popular model in the market, like all these three, i4, iX. So after i3, then BMW start to go for the i4 and iX. And also you can see there's a many other model here. So there's i4. So gradually they improve the size and the power level for i4 and iX. Of course, the price also quite sensible, I should say, really high. That iX will be 96,000. That would be quite a lot as compared to the Tesla. Of course, at least it's BMW. Some people prefer that than Tesla. But the sales of BMW iX is still not really good at the moment. The range you can see there will be 500 something km. It's not that large number as compared to Tesla Model Y or or model X, the acceleration is good, 3.6. 3.6 seconds supposed to be really good anyway. But one question we'd like to ask you will be for vehicle or electric vehicle. Do you think the 0 to 60 miles per hour acceleration time will have a limitation? How far we can able to decrease the time? Do you think there's limitation, or if you put higher power motor, you can able to reduce from 3.6 seconds to 3 seconds, 2.5, 2 seconds, 1 second, 0.5 seconds? Do you think that would be possible? What do you think? What? Any limit?
There is a limit, like 2.8, I believe. Yeah, because if you just keep putting more and more power in it, the wheels wouldn't just get the traction. After some point, it'll just spin right over there.
You mean that is limited only by the power rating for the motor, or by what?
When we try,
By the motor drive?
because if you need a higher power, that means higher torque in the motor. That means
You see, I think the limit is not really the power rating for the motor. My limit means, for instance, you can able to fulfill really high performance motor, really high performance. You can use 200 horsepower, you can use 400, even those 200 to 400 horsepower motor will not change by a great deal in terms of the weight and volume. And even you can pick a really high power motor there, but of course you consume too much power, the mileage is not that long anyway. But at least you are able to make the 0 to 60 miles per hour second to be much lower. But my question would be, would there be any limit? Of course, you may say the power rating of the motor, but in the future, you can able
otherwise there might be thermal runaway.
in the thermal runaway.
Yes.
That relates to the
Battery can heat up.
yes or no, right? Because if I only looking into the highest power acceleration within short period of time, like a racing car, I don't care about the thermal issue because the vehicle only run for a few minutes, right? But do you think that is a limitation? What do you think?
I mean, if you drive too fast, you need to consider our driver.
Human.
Yeah, the
But
human,
autonomous driving, we have no driver, right?
all right,
Mm.
then,
So it seems all your thinking go to the driver, the motor power, the battery. But actually, somebody told me there's a physical basic law, basic phenomenon that limit the number of seconds here. No matter how good you perform, how light your material can go to, how powerful your motor can go to, no matter what you can do. But there's basic physical phenomenon. You can't reduce that 3.6 seconds to less than 2 seconds or something like that. I don't remember the number of seconds. There's a physical phenomenon. You may need to do some searching. That kind of the phenomenon I check it is really much reasonable. How I get that is from my little boy doing a physics Newton law of motion. I discovered that. So do go back to think about, would that be basic phenomenon restrict us to further reduce the number of seconds for that acceleration due to whatever you can think of.
Air resistance.
That's nothing to do with air resistance.
Friction between the wheel and the ground.
Friction between the wheel. You see what your acceleration is, your forward acceleration, what can you able to achieve? That must be controlled by your friction at the bottom. If no wheel friction, how can you accelerate? You're not flying vehicle. Flying vehicle, if you injection, you can do whatever speed because based on momentum. But for ground rotational acceleration, it's based on friction. No friction on the ground, you have no acceleration, no force, no forward force. That will limit your maximum force. When you limit maximum force, you limit your acceleration. So that means this will have a limit. So that means my next assignment will ask you to investigate this problem, give me a feedback to see what is that limitation, what's that, do a case study tell me for certain vehicle, you can think of what is the highest acceleration you can achieve for our, in terms of our law of physics. So that means if somebody tell you my vehicle, my motor, my EV can able to accelerate 0 to 6 in 0.5 seconds, is lying. That's not physics. Impossible. That's a limitation. Don't go home to think about that. I find it out when I taking my EPP will do some high school physics, and then I discovered that really basic law, but it's quite interesting. Anyway, so like Porsche, there's also quite a famous brand and getting popular. I think gradually you can see that some high performance brand, they tend to use high voltage of the battery. Nowadays, all the new version, the voltage are go up to 800 volt because they like to have high power. High power, we want to reduce the current. You can see that for this type of battery will be 79, and then the motor power also will be quite high power of the motor. So in this case, they want to have high power charging 270 kilowatt, and the battery is 800 volt. So latest model for many EV, the battery got to 800. For old model, 400, 500 will be quite popular. So there's something quite interesting. So today, all the latest model 2025, they started move on to 800 volt of DC voltage. That means each of the battery will be 3.7 volt. They did hundreds of the battery to add up to become 800 volt in order to reduce the current. But in this case, the charging, you need to have a really high power charging. So that means high power charging, they now close to 270 kilowatt. So not that many chargers able to do that. In many city charging, that will be still difficult. You can imagine your whole house, probably in our whole house, the PG&E able to provide only 40 kilowatt for your whole house. So that means when you charge a vehicle, that means a few houses add together to charge your EV. So that will be one of the difficulty in the future charging station design. We don't have sufficient power. You see, each household have one vehicle. Then how can we increase from 40 kilowatt to 270 kilowatt? Impossible. PG&E need to increase their capacity by how many times? 6 to 7 times. Yeah. They need to build 6 to 7 more generator. Impossible. So that will going to be a big problem. So you can see from all this scenario, you can imagine in the next many years, which market will be something we need to look into. Charging market. Yeah, that would be quite a big business or quite a difficult business anyway. Audi, yeah. Audi, this one also very interesting vehicle. The battery, you can see that 93 kilowatt hour. The mileage is not really sensible, only go up to 725 km. It's not compatible, but the vehicle look really nice. And I think the acceleration also quite interesting. I don't have the acceleration here, but the voltage also, you can see 800 volt. So all the high performance vehicle, they all go to 800 volt DC. So BYD 10 is another interesting vehicle. So one of also quite of the second best seller in BYD. So the motor, you can see that they use the whole 110 of the motor system. So that's another. You see BYD, many of their model, they use this kind of the special name Han Yan because they relate to the name of their dynasty. Volkswagen, IDE, and then the EQC. That's also quite a famous model around 10 years ago. And many people thinking about that because I think the cost is really much reasonable. And of course, it's come from Mercedes-Benz. So that's also quite a good model. many people during that time try to use it. And the plug-in charging, the DC will be 110, the AC charging 7.4. Later on, I will also show you the difference between AC charging and DC charging. You can see that here, 7.4 with AC, DC with 110. You can see that DC charging usually will be higher power than AC charging, right? That's alone. Anybody can tell me why is that? How about the gentleman? Could you tell me why AC? Why can't we use high power AC?
I haven't studied electrics.
Oh, you don't study electricity. How about the gentleman? What do you think? So next few lecture, I will show you why is that. I'll show you the basic principle for the charging. Then you know going to be why DC charging will be more powerful than AC charging. So we'll show you in next few lecture. So here we will go back to Nissan Leaf, also a conventional car, classical vehicle nowadays. And also, anyway, it's close to 20. Can I finish it? I think I can finish it now. And so there's another low-cost model. Low-cost model is quite funny, right? Many companies, they try to issue the really low-cost model, talk about a few $1,000. You see a motor, if you don't have high demand, only a battery. Motor, simple battery, simple motor, you're able to provide just a EV with a car body. So that's why you can able to produce a low-cost solution without any sophisticated power management control. It's a simple vehicle for transportation. Here we many brands in Asia or in India will produce this kind of the low-cost solution to you. Now here in China, you can see that that's in the renminbi. You can say divide by, divide 8 will become US dollar. So they are really low cost. Some of them will be as low as this, just a few $1,000. You can get a more model. So this vehicle also really special because one of the cheapest vehicle in Asia is only 34,000 in renminbi. So that means roughly about 4,000 US dollar. Really cheap, really low cost. But the performance is quite reasonable. If you don't demand for too much, that is a good vehicle for city driving. So this is one of the top seller in China. So that's really good. But the thing is, this one cannot export to other country, only inland. So that's why you can't do that. But India also have a lot of the good vehicle, also low cost, like this few. Also, you can see that the price are also quite reasonable and the outlook of vehicle also good. So probably we may not able to finish is that 20 past. So let's start from here. So any question before we join the class? Okay, then that's all. Then see you again on Thursday then. Bye-bye.